7.4 Day 1 is partial fractions. Our goals are to recognize partial fraction decompositions of rational expressions and find partial fraction decompositions of rational expressions. So just a little bit of an introduction. In this section, you're going to learn to write a rational expression as a sum of two or more simpler rational expressions. For example, the rational expression below, x plus 7 over x squared minus x minus 6, can be written as a sum of two fractions with first-degree denominators. So you can see that it changes to 2 over x minus 3 plus negative 1 over x plus 2. Each fraction on the right side of the equation is a partial fraction, and together they make up the partial fraction decomposition of the left side. So here are just some rules of doing decomposition of numerator over the denominator into partial fractions. Divide when improper. So when n over n of x over d of x is an improper fraction, meaning the degree of the numerator is greater than the degree of the denominator, you're going to divide the denominator into the numerator to obtain this here, right? So the polynomial, the quotient goes here, and then plus the remainder over the divisor. And then you're going to apply steps 2, 3, and 4 to the proper rational expression. And then note that n1 to the x is a remainder from the division, right? So remember that the remainder goes here over the divisor. And then after that, we're going to factor the denominator. And so today, that's what we'll do in this lesson. If it's factorable, we will factor it into factors of the form px plus q raised to the m and ax squared plus bx plus c to the n, where ax squared plus bx plus c is irreducible. Today, we're going to focus on linear factors. For each factor of the form px plus q to the m, the partial fraction decomposition must include the following sum m of fractions. So you're going to see it. We have so we have a1 over px plus q plus a2 px plus q squared plus all the way to px plus q raised to the m. Okay, and then tomorrow, or the next lesson, we're going to look at quadratic factors. And so we write it in this way, and then it's squared, and then so forth. And notice that here in the numerator, it is linear. It's bx plus c, and then all the way to here. And then for linear factors, it's just a constant at the top. Okay, so just kind of looking at the differences between the two. Again, this lesson is going to focus on linear factors only with constants on the top. So let's take a look at partial fraction decomposition. The examples in this section demonstrate algebraic techniques for determining the constants in the numerators of partial fractions, so constants. Note that the techniques vary slightly depending on the type of factors of the denominator, linear or quadratic, distinct, or repeated. So let's take a look at distinct linear factors. Okay, so that's what we'll focus on. Right, the partial fraction decomposition of x plus 7 over x squared minus x minus 6. So if you notice with this rational expression, we can factor the denominator. So the denominator will factor to, and I'll write it over here, to x minus 3, x plus 2. So once we have that, we're going to write the form of decomposition. So we will write the first factor here, x minus 3, and then a is in the numerator. Okay, so we write a constant on top, plus b over the other factor, x plus 2. So that is a form of decomposition. And again, it's when you have linear in the denominator, we write a constant in the numerator. Now let's solve. So what we're going to do is we're going to multiply by the LCD to get the basic equation. LCD to get the basic equation. The LCD is this, so x minus 3 times x plus 2, and you're multiplying it to every single term. And so notice on the left side that the denominator completely cancels, so we have x plus 7 equals a times what's missing, the x plus 2, plus b times the x minus 3. So now we're going to choose any values in order to solve for a and b. Now we can choose values that are convenient. So in this case, what is convenient? Well, what's convenient is a negative 2, because that'll make that 0 and I can solve for b. And then the other one is a positive 3. So you choose what's convenient. And in this case, we're going to choose x equals negative 2 and x equals 3. So let's do that. X equals negative 2, so we're going to plug it in. So negative 2 plus 7 equals a times negative 2 plus 2 is going to be 0, plus b times negative 2 minus 3. So now this simplifies to 5 equals b times negative 5, or b equals negative 1. So we have one of our terms here. Now let's try x equals 3. So let's plug it in. 3 plus 7 equals a times 3 plus 2 plus b times 3 minus 3 is 0. So we have 10 equals 5a, or a equals 2. So now we can write the partial fraction decomposition. We have x plus 7 over the x squared minus x minus 6, and that's going to be a, which is 2, right? So we're plugging it back into here. So a is 2 over x minus 3, and then you could say plus or just minus 1 over x plus 2. So that is the partial fraction decomposition. You could do a check. Okay, so let me just do a check once, just so you can see what that looks like. And so what happens is that if you add these together on the right side, or subtract it, then you should get this back, right? So that's how you check. And so let's do that. 2x minus 3 minus 1 over x plus 2. We're trying to check to see, does that equal x plus 7 over x squared minus x minus 6. So in order to do this, you need to multiply by x plus 2 on this right side, and x minus 3 on this side. Sorry, this is the left and the right. And then you get 2x plus 4 minus x plus 3 all over the x plus 2 times x minus 3. So you get x plus 7 over x plus 2 x minus 3. And then, of course, if you multiply that back, you're going to get the x squared minus x minus 6. And so that does equal. So that's the way that you would check this. So go ahead and try this example here. Write the partial fraction decomposition of x plus 5, or 2x squared minus x minus 1. All right, if you tried this out, the denominator factors to 2x plus 1 times x minus 1, and then you write it here, write the form of decomposition, then you multiply by the LCD, so you come up with this basic equation, and then you solve, you use 1 and negative a half, so you would find that b is 2 and a is negative 3, and then just make sure you're plugging it into the right spot, so a goes here, so negative 3 over 2x plus 1 plus 2 over x minus 1. Now, one little thing to note is that it doesn't matter which one gets written where, right? So maybe you wrote your x minus 1 first and 2x plus 1 second. It's fine. It'll still be the same numerator on top, regardless of where this ends up. So there's not a certain way that you have to write it. You will end up with the same answers.